Hello geographers and welcome to this coast lesson about erosional landforms. Today we're going to focus on caves, stacks and arches. I am really lucky to live by the stunning Durdle and it's absolutely beautiful. For today's lesson you're going to need a pen, a pencil and a piece of paper. So in a second I'm going to ask you to go and get them and make sure you've cleared away all of those distractions. If you need to go and move somewhere quieter, please do so. Go and grab the stuff you need and we will start the lesson. Excellent. So your title is on the screen, Erosional Landforms number 3. I would like you to write down cave, arch, stack and make sure it's underlined nicely. Let's jump straight on in there with how do caves, arches and stacks form. This is a great photo to show different coastal landforms. Here we can see caves, arches and stacks in Iceland, all on one headland. How do headlands change over time? Destructive waves erode the headland through processes such as abrasion. Abrasion is the wearing away of cliffs by sediment flung by the breaking waves. And that sediment acts like sandpaper, scraping it away. Faults and joints in the resistant rock are more vulnerable to erosion. Hydraulic action and abrasion will widen these. Hydraulic action is when breaking waves compress pockets of air in the cracks. The pressure eventually causes the cracks to widen. Eventually, abrasion and hydraulic action are going to enlarge the cracks into a cave. Waves continue to abrade the cave, making it deeper and deeper. If there was a cave on both sides of the headland, they will eventually erode through the headland, creating an arch. This arch is enlarged by waves at the base and weathering at the top. And remember, weathering is the wearing away of rocks in situ, so where they are. As the top of the arch is unsupported, it suffers from weathering, and eventually it will collapse due to gravity. This leaves an isolated pillar of rock called a stack. And you can see on the diagram with those dotted lines where the arch used to have been before it collapsed. Sometimes you're going to see all of these landforms all on the same headland. So here, if we start at the left of the picture, we've got a small cave, then there's a larger cave, then we've got an arch, there's some faults in the end of that headland, and we've got a stack at the end. Something that's interesting as well is around the bottom of that arch and the bottom of the stack, we've also got a wave-cut platform going on here. Let's test you. Which type of wave creates a cave? You've got 3 seconds. Tell me out loud. It is destructive. We remember that word. Destructive waves destroy. If you're destructive, you're destroying things. Put these landforms into the correct order. So jot down the letter. You've got cave, stack, fault and arch. Jot down the 4 letters in the correct order. Right, now you've got them written down. You should have C first, fault. Then you should have A, cave. D, arch. And finally, B, stack. So those letters, one last time, C, A, D, B. Which is not a reason why the top of an arch collapses. 5 more seconds to think about it. And the answer is hydraulic action. Hydraulic action is linked to waves and those are found at the bottom. So the bottom of the arch will be eroded by hydraulic action, but the top of the arch is going to collapse because of weathering and because gravity is pulling it down where it's unsupported. Task time. Draw a labelled sketch in pencil of the landforms. So you're going to copy my diagram really simply in your pencil and you're going to label the landforms. The 4 landforms I would like you to identify are stack, cave, arch, and faults. There's a challenge here as well. I would like you for each landform to identify the key process involved in its formation. If we look at an example of this, here you have a fault, and that fault is created and enlarged by hydraulic action. Time for you to tackle it. Pause the video to complete your task and press resume once you're done. Right, let's get marking. So, how did you get on? You should have been able to identify the fault created by hydraulic action. There were several caves. Those are created by abrasion, so waves scraping away at the cliff. Abrasion is going to make that cave get deeper and deeper. Next, there is an arch, and that arch would have been created by abrasion because the waves, the destructive waves, had to abrade the back of that cave until it wore through the headland. Then we have, finally, the stack. That stack was created because of gravity and weathering of the old arch roof. So gravity has pulled that arch down where it was unsupported. Here is a photo of Old Harry Rocks on the Dorset coastline. It's a really famous example, and you can see there are several stacks detached from the cliff. If you have a look at the bottom of the cliff, you can also see that it's got a wave-cut platform around the cliff and the largest stack. Then another famous example, this is Durdle Door, which is a really famous arch. It's very spectacular. Let's look at map skills. Map skills are all of our exam papers, and it's really important as a geographer that we get these right. I've got a copy of a 1 to 50,000 OS map, and it shows Old Harry, that famous stack, up in the top right corner. So a stack on a map is outlined by a black line, and it's often detached from the coast. Also on here, down between the pinnacles and Ballard Point, are cliffs. Well done, those of you that got that. So these are small black semicircles set back from the coastline. Also, you can see that there are 2 areas of sandy beach on this map. We're going to practice grid references. They can be a little bit confusing, but as long as you follow some simple rules, they're fine. We're going to look at the grid reference of A. And to do that, we want the lines that form the L shape around the square. So the line to the left and the line underneath. So we've almost created a seat for that A to sit on. The first thing we do with grid references is we go along the corridor. 04, 05, 06. And 06 takes us to that first line of the L. Along the corridor is 06. Next, we climb the stairs. So we're going to climb up the stairs to 81. So the 4-figure grid reference for A on this map is 06, 81. It's time for you to have a go. In which grid square is the stack? And it's probably best for you to pause the video here so you've got your time to work out where the 3 grid references are. The answer was, let's have a look at Old Harry. We're going along the corridor, 04, 05, up the stairs to 81 to 82. So the answer is 05, 82. How did you do? Another map skills question. This time we're going to look at which grid square has many cliffs. You've got 3 options. So again, pause the video, work out which 3 grid squares they are, which one of them has cliffs. A is at 0382. B is 0580. And C is 0481. The answer is C, 0481, and you can see the cliffs around Ballard Point. This is a really tricky question. These come up quite often in the exam. Which way is the photographer facing? So we've got a map extract, and the first thing to remember is that north is always at the top of the map. We've then got a photo of Old Harry Rocks. And the photographer is stood on the land. You can see the grass in the bottom left corner, and he's looking straight at the large stack of rock. You can also see to the right of the shot that there is the smaller stack. So that enables us to decide he's looking at the larger stack. If we go over to the map, the photographer would have to be stood on the grass and he's looking at that rock stack. If we look at the direction of that pink arrow on the compass, it would be northeast. So it is really tricky to get these right. You've got to have a think about what the camera is looking directly at and how to line that up on the map. Your go now. Pause the video, take as long as you need, have a go, but make sure you do try. Don't just sit there waiting for the answer. Give it a go. The first thing I would have looked at then is that this drone, I think, has taken this photo, is looking along the stacks at the mainland. So if I take that arrow away, almost directly with the stacks in line. If I put that same arrow lining up the stacks, looking at the main bit of land, this time you can see that the photographer is facing, tell me out loud what you've got, be brave, it is southwest. Big task for you to show me how much you've learnt now. Explain the processes involved in the formation of the landforms shown in the photo. Let's unpick it. Explain the processes. So processes that you need to mention are things like abrasion, hydraulic action, weathering. In the formation of the landforms, there's an S on the end of that word, so we're looking for more than one landform. We can see Old Harry, so we know that there's a stack. But if you look at the base of the main large stack in the centre, there is a small arch that has appeared. You could also argue that around the base in some areas there's a wave cut platform, but I'm going to ask you just to write about the arch and the stack today. A successful answer is going to write a step-by-step formation. First this happens, next this happens, finally. I would like you to explain the processes, so define them, and the ones I would like you to define are abrasion, hydraulic action, and weathering. Let's go. Pause the video now, complete your task, and then come back and join me again. Good luck. How did you get on? I've used a key in this answer. I've put all the landforms I've mentioned in green. I've put the processes I've included in pink, and I have put the processes where I have explained them in navy. The arch and stack shown in the photo were created by coastal erosion. Can you put a big tick if you've identified that these are erosional landforms? First of all, destructive waves erode the cliff, widening faults due to hydraulic action. This is breaking waves, compressing pockets of air in cracks. Give yourself a tick if you've got hydraulic action creating the fault. These turn into caves, which gradually deepen due to abrasion. Sediment in the wave is flung at the cliff, causing it to wear away, and may eventually break through a headland, creating an arch. Make sure, if you don't have these processes explained, so the bit in navy, that you pause the video and add those in. This arch is weathered, so wearing away of rock in situ at the top, and as it is unsupported, eventually collapses due to gravity. The isolated pillar of rock remaining is called a stack. So one final check. You should have faults, caves, arches, and stacks mentioned. You should have process words, so any of the words in pink: erosion, hydraulic action, abrasion, weathered, and gravity. And finally, we're looking for those top marks to get those processes explained, the definition of them in brackets, which is the navy in this answer. Pause the video if you need more time to improve your own work. Amazing. That brings us to the end of today's lesson. We've learnt about how caves, arches, and stacks form, and we've linked it really carefully to those important processes like weathering and abrasion that make our writing sound very impressive. But don't cave just yet and turn on the TV. We need to go on to the next page and do the quiz. It helps us revisit all that we've learned today, so we're less likely to stack it in an exam. Can't wait to see how you've gone. Thanks very much for your time. Take care, and I cannot wait for you to join me soon as we start to move on to look at depositional landforms. Have a great day.